XPENG just announced that its first mass-produced Robotaxi rolled off the production line in Guangzhou. That sentence sounds like a car company update, but the AI story is bigger. This is not a chatbot, not a benchmark, and not a lab demo. XPENG is trying to put a vision language action model into a manufactured vehicle, then use the same physical AI direction across robotaxis, humanoid robots, and even flying cars. Today, the signal is simple. AI is moving from screens into machines that have to act in the real world.
The production line part matters because autonomy usually gets shown as a polished demo. A company drives a carefully selected route, posts the best clip, and everyone debates if the model looked smooth. XPENG is making a different claim. The official post says this is a factory-ready robotaxi platform built for large-scale implementation. That does not mean every hard problem is solved. It means the AI stack is now being packaged like a product. Sensors, compute, vehicle body, deployment partners, and a path towards city operation. The subtle shift is accountability. Once something is mass-produced, it needs repeatable quality, maintainable hardware, and software updates that work across many identical units. Not one perfect prototype.
Look at the hardware signal. XPENG says the Robotaxi has 4 Turing AI chips, 3,000 TOPS of onboard compute, and 33 high-performance sensors, including LiDAR, 4D millimeter wave radar, ultrasonic radar, cameras, and a microphone. That list matters because real-world AI is not just about having a smart model. The machine needs dense perception, fast inference, and enough redundancy to handle weird roads, people, weather, occlusion, construction, and all the small edge cases that never show up in a clean demo. The microphone detail is interesting too, because future physical AI systems may need to reason from visual, spatial, and audio context at the same time.
The interesting model phrase is VLA 2.0, Vision, Language, Action. XPENG describes the robotaxi as a brain, cerebellum, and body loop. The VLA brain perceives and understands the environment. The cerebellum handles path planning, trajectory prediction, and motion control. The body executes steering, braking, and acceleration. That is why this feels different from normal app AI. The output is not a paragraph. The output is movement. The quality bar is much higher because every mistake has a physical consequence. In a chat app, a bad answer can be regenerated. On the road, the system has to choose a safe action before the scene changes again.
The deployment detail to watch is Alibaba AMAP. XPENG says the two companies are targeting a joint robotaxi launch in 2026, starting in Guangzhou and then expanding nationwide. XPENG also says it will release a robotaxi SDK to ecosystem partners. That is important because a robotaxi business needs more than model intelligence. It needs maps, routing, dispatch, operations, safety monitoring, local regulation, and user demand. If the SDK opens up real integration, XPENG is not just selling a vehicle, it is trying to become a physical AI platform. That is the strategic wedge. The model does the driving, but the ecosystem determines whether the robotaxi becomes a service people can actually use every day.
The bigger reason this is worth covering is convergence. At AI Day, XPENG framed VLA, VLM, and VLT as the base for physical AI across robotaxi, the iron humanoid robot, and its flying car direction. That does not mean all these machines share one identical brain today, but strategically, the company is pointing to one AI infrastructure layer that can understand scenes, plan actions, and control different bodies. If that works, the car is not the end product. It is the first high-volume training ground.
The trap with stories like this is to treat the rollout photo as the finish line. It is not. The hard part starts after the launch photo. Robotaxi systems have to handle long-tail driving situations, construction zones, bad weather, confused pedestrians, emergency vehicles, mapping gaps, sensor degradation, and human behavior that does not follow the rules. They also need economics that work. If the vehicle costs too much to operate or needs too much supervision, the AI may be impressive, but the business may still be fragile. That is why the next year matters more than the announcement day.
So the takeaway is not that robotaxi is suddenly solved. The real takeaway is that physical AI is entering a manufacturing and deployment phase. The next proof points are boring but critical. How safely it handles edge cases, how regulators treat it, how quickly AMAP integration moves, whether the SDK creates a partner ecosystem, and whether VLA 2.0 improves with real operation.
This is why XPENG's production line moment matters. The AI world has spent years arguing about models on screens. The next fight is models inside machines. Even if the timeline moves slower than the launch language, the direction is clear. The companies that connect models to sensors, actuators, factories, and real distribution will shape the next chapter of AI.